Okay, our topic today is operations with radicals. So that's anything underneath a root sign. We're just going to stick with square roots today. And we're going to look at the algebra and how to put things together. Let's look at a few examples and kind of see how things work. So our first example, let's say I've got the square root of 25 times the square root of 4. So usually when we solve this, we say the square root of 25 is 5 and the square root of 4 is 2. We know 5 times 2 is 10. So we're done. Well, what would happen if, instead of writing it like that, I wrote 25 times 4 all under my square root? Well, generally we would simplify what's underneath the root sign first. So 25 times 4 gives me 100. And then what's the square root of 100? It's 10. Ooh, same answer. That's pretty cool. Let's try another one. Let's say we've got the square root of 16 times the square root of 9. And let's see if we get the same result. So individually, the square root of 16 is 4. Square root of 9 is 3. 4 times 3 is 12. Okay, now let's see if our pattern holds. So, square root of 16 times 9. Well, 16 times 9 gives us this 144. And what do you know? The square root of 144 is 12. They're the same. Okay, so that takes us to our first law. So our law, our rule, our simple way of writing it, our general way of writing it is square root of A times the root of B is the same thing as A times B under the square root. Okay, let's talk about a situation when they aren't perfect roots. So these ones were perfect roots. It worked out beautifully, nice and easy. But what about if I had, let's say, square root of 6 times the square root of 4? Well, I don't have a nice easy square root of 6, so I'm just going to leave that alone. I do have a nice perfect answer for square root of 4. It's a perfect square. So that would be times 2. And what we're going to do this unit is we're going to write these things as exact answers. So 2 root 6 is as far as we're going to go. We're going to call this a mixed radical. And because I can't bring 6 down any further, this is going to be in lowest terms. So this one here is going to be our lowest terms. This is going to be our aim when we simplify. Well, let's look at it. Same as what I did over here. Well, what about if they were both under the same root? So, what if I had 6 times 4 under the root? Well, 6 times 4 we know is 24. And then to simplify it, we're going to break it down into this. So we end up with that. And that's going to be our goal in the next examples when we start simplifying. Okay, so that would be an entire radical. Before we go any further with some of the algebra that we're going to cover today, let's just make sure we've got a few very important simplified concepts. What's that? C? D? So let's remember that if I had the square root of 5 squared, well, the square gets rid of the root. So my final answer would be 5 because the 2 undoes the root. If I have, let's say, the square root of 5 cubed, well, that means I've now got 3 of these roots. So I'm just going to write that one out a little bit further. So that means I've got root 5 times root 5 times root 5. So when I've got the 2 of them side by side like this multiplying, that's the same as my square. So that gets rid of my root sign. So that gives me a 5. And I still have this last one here. So I've got 5 times root 5. We don't need to write that times in between, so we would normally write that as just 5 root 5. Okay. All right, time to do a little simplifying. So when we simplify radicals, we want to leave them as a mixed radical in the lowest term possible. So we don't want to have any perfect squares underneath our root sign. What we want to do is we want to see if any perfect squares are factors of the number underneath. So, what do you think? Remember, our perfect squares are 4, 9, 16, 25, 36, 49. So you keep working your way up. So that would be 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, right? As we go along. So 72 breaks down to the square root of 36 times 2. And we know the square root of 36 so I'm just going to split them up like this. Square root of 36 we know is 6. Can't take root 2 any further. So my final answer is 6 root 2. Okay. How about if I have a number in front? So let's say I have 5 root 27. How are we going to handle that? The 5 is just going to tag along. We still have to look under the root and see if we can find a perfect square that goes into 27. So, well, we know 25 is not going to be a factor. It's too close. 16, no. 9, oh yeah, 9 times 3 gives me 27. Okay, so the 5 tags along. Under the root sign, I'm going to write it as 9 times 3. I know I'm allowed to break it up to become root 9, root 3. And I know root 9 is really 3. So I now have 5 times 3, root 3. Finish off, 5 times 3 is 15, root 3. And there's my final answer. Now let's do the reverse. So example 2 says we want to express as an entire radical. So I'm starting with a mixed radical, and I want to get that coefficient in front underneath the root sign. So to do that, to put this under the root sign, we're going to have to square it. So when it goes under the root sign, I now have squared it times the number that was already there. So the square root of 16 times 5, and then 16 times 5 is 80. So my final answer is root 80. That's my entire radical. Let's do the same thing for number B. Note now I have a negative sign. You can't put a negative sign under a square root, so it's going to tag along in front the entire time. Let's do the same method. So 6 is the same thing as the square root of 36. Square root of 36 is 6 times root 3. So we've got negative 36 times 3 all under the same root equals negative 108. Good. Okay, let's start doing some simplifying. So example 3 has me doing root 5 times root 11. Neither one of these has a perfect square. Neither one of them has a perfect square as a factor. When we put them together under the same root sign, we've got 5 times 11, which gives me root 55. And I can't break that down any further, so that one is simplified already. B has me doing negative 4 root 6 times 2 root 6. So now I've got coefficients to worry about. I've got 2 different radicals to worry about. Notice that they're both the same, so we've got a nice little trick here because that's the same thing as root 6 squared. To handle this one, I'm going to take my 2 coefficients in front. So I've got negative 4 times 2, and then I put my 2 radicals at the end. So I've got times root 6 times root 6. Negative 4 times 2 gives me negative 8. Root 6 times root 6 gets rid of the square because it's squared. Negative 8 times 6 gives me negative 48. Okay, I'm going to add a couple more examples into this. So the examples are from me. Let's simplify the square root of 63. So you think to yourself, what perfect squares go into 63? Well, does it divide by 4? No. Does it divide by 9? Yes. 9 will work. All right. So this gives me root 9 times 7. Well, that gives me the square root of 9 times the square root of 7. Square root of 9 is 3. Final answer is 3 root 7. Excellent. Let's try one that has a few more options to it. Let's try the square root of 128. Now I'm going to go through the same method, and I'm actually going to start with the smallest perfect square factor that goes into this, just so you can see that you can do it. So 128, does that divide by 4? Oh yes, it does. Okay. So that gives us 4 times 32. Square root of 4 times the square root of 32. I know the square root of 4 is 2. Root 32. Now since that's still a big number, I do want to go back through my list of perfect squares and check again. So let's see, 32, does that divide by 4? It does. Let's see if we can do more. Does 9 go into it? No. But does 16 go into it? Yes. Okay. So, let's see. My 2 is still out front. I now have 16 times 2 underneath my root sign. So that gives me 2 times 16 times root 2. 16, so the square root of 16 is 4. Root 2, final answer, 2 times 4 is 8. Root 2. So sometimes you can do it all in one step, and sometimes you might not find the biggest perfect square factor that goes into it, and that's fine. Just keep going. Okay, we're going to do one last set of examples here. These ones aren't from your textbook, but we are going to do some expanding brackets. So let's see how this works. Let's say I had 5 root 3 bracket 2 minus root 6. Well, we're going to use our same distributive properties that we did usually whenever we are expanding a bracket. So we're going to multiply the outside by the first term. So you get 5 times 2 root 3. I like to put the 2 numbers at the front, followed by any radicals. It keeps things in order, just like if you had an X or a Y or something. And then do your number in front times your second in the bracket. So we've got a minus 5 root 3 times root 6. So we're going to use our rules. 5 times 2 is 10 root 3 minus 5. And then because these two are both under a square root, we're going to put them under the same root. So you get 3 times 6 under that root. So we've got 10 root 3 minus 5 root 18. Pay attention. 18 breaks down. 18, remember, is 9 times 2. And 9 is a perfect square. So let's finish this off. 10 root 3 minus 5 root 9 times 2. 10 root 3 minus 5 times root 9 is 3. Root 2. 10 root 3 minus 15 root 2. Phew, it's a lot of lines, but it's just simple multiplying. We didn't even put anything together because our 2 radicals don't match. We're going to worry about that one next lesson. And that's how we do it. Let's do one more of these types of examples, and then we'll be done. So let's say this time I've got a 2 root 5 outside my bracket, and inside my bracket I have a 4 root 2 minus 7 root 3. Expand our brackets. So we're going to multiply what's outside times the first one. Again, I'm going to keep the whole numbers in front. So I've got 2 times 4. And then I'm going to follow it by my 2 radicals times root 5 times root 2 minus my outside times my second one. So I've got 2 times 7 times root 5 root 3. Combine things that we can combine. So 2 times 4 is 8. Square root 5 times 2 is 10. Minus 2 times 7 is 14. 5 times 3 is 15. So those guys go together under a root. No perfect squares go into that. No perfect squares go into that. So we're done. Well done, guys.